Hello, welcome to the Bits and Bäume stage for the next talk. Please try to find a place in the shadows. Have your water ready and so on. I should remind you, if you're leaving camp and you still have stuff you don't want to take back and it's too nice to trash, you can go to Infodesk and try to donate it there, and they will try to do something useful with it. As I guess the rumors have already spread that there's a little bit of COVID going around, it's not more than what would have been to expected as such a huge crowd. If you have questions regarding that, you can go for testing at CERT, and there are masks and whatever stuff available at CERT Heaven and Infodesk. So, welcome to the Bits and Bäume stage for the next talk. And for that, I welcome Holger on stage. And he will talk about reproducible builds, the first 10 years. Give him a warm welcome and enjoy the talk.
Hello, thank you. I'm Holger. I live in Germany. I work a lot on Debian and since a long time. Also work on reproducible builds since 10 years. Even though I work on I really love Debian, I try to make all software reproducible. And this is a pretty complex topic. So just ask me anything, anytime. I'm happy to talk about it. And I will miss lots of things in this talk. So, reproducible builds. This is not my talk. This is a list of people working on this. Has been working on it. It's from the webpage. It's about 100 people, but I think the list is at least double as long. So, who of you has heard about reproducible builds and why it's useful? Okay, nice. Who has contributed or is contributing? Some people. Nice. Who knows reproducible builds have been around for more than 10 years? A few. For more than 30 years? This is really an old idea, actually. Who has heard about SBOM files? Hey, SBOM is some fancy new thing that the US government wants. Software bill of materials, and we have them since 9 years as build info files. They're basically the same, just the format is a bit different. And we need people in all upstream projects and elsewhere to make sure that their software builds reproducible. So we need your help. It's hot. And the goal of the talk is to get you involved. Because we have done a lot, but it's still a lot to do. So, introduction. The problem is that source code of free software is freely available, but nobody uses source code. We all use binaries, and no one really knows how they really correspond, even those building the binaries, because you need to trust the computer and the build chain and whatnot. And so there's various supply chain attacks. And in 2007, somebody suggested on Debian Devil to create reproducible binaries, and that there was a huge thread with 50 mails, and people said this is not possible. And the same even happened earlier in the year 2000. Same idea, it was shot down quite quickly. And then in 2017, John Gilmore from Cygnus wrote that GCC was reproducible in the early 90s on several architectures, and not only GCC, but also the whole toolchain there. And that bit rotted away. And now, 5 years ago, the GCC people weren't even aware anymore that it was reproducible in the 90s. Now, fast forward to this year. In April, there was a mail on the WireGuard mailing list that their VPN client is now reproducible on their webpage. The build is identical in Google Play Store and F-Droid. And that's pretty wow, and we were not even informed. They just did it. And it's pretty cool. I'm really happy. So our mission is to enable anyone to independently verify that a given source produces bit-by-bit identical results. So we are an important building block in the supply chain to make supply chains more secure, nothing more and nothing less. And insecure software is still insecure software, just distributed securely. And then it has nothing to do with making the software more secure in itself. And by now, this has been widely understood. We have documented this on the webpage. The resources are like 50 talks we've been given on various conferences in the last 10 years. We have common pitfalls and problems and solutions. There's about 10 or 15 scientific publications by now. And there was this White House government statement in 2001, which requires these SBOM files for governmental software. And on page 42, they also recommended reproducible builds. And reproducible builds really are verified SBOMs. Because SBOM is just a statement from the manufacturer, this should be in there. And everybody can lie about this. And reproducible builds gives you verified SBOMs. So we've made a definition to really define when is a build reproducible. And a build is reproducible if given the same source code, build environment, and build instructions. Any party can recreate bit-by-bit identical copies of all specified artifacts. And I've also intended this to define what build environment means, what the source code means, and this is there on this page so that we are all on the same page when discussing this. And how did we get there? With money was a reason, and Edward Snowden. Why money? Bitcoin. Bitcoin, I don't know when since Bitcoin is probably 2009 or something, and 2011, well, it's older, but in 2011 when Bitcoin has a market capitalization of $4 billion US, they wanted to be secure that if there's a malicious backdoor Bitcoin client which steals all your money, that they could not be blamed because the sources are available and it's not backdoored. So they made Bitcoin reproducible in 2011. Which then was an inspiration for the Tor browser people. And Mike Perry made Tor browser available in 2013, directly after the Snowden revelations. And that is Firefox Tor browser, and that's one of the biggest software projects in the world. It's like 70 megabytes, the binary, and it was possible to make this bit by bit identical. And of course, it was not only this, but many people did a lot of work on this. So Luna, fellow Debian developer, made a workshop at DebConf 13 in 2013 and gathered 30 Debian people and discussed whether it's possible. And then there was another BOF at DebConf 14. And there were patches for dpackage to sort the files inside in a deterministic order and create build info files so that the instructions, what is needed, what's the build environment, what are the build instructions to build a package. And in September 2014, I started systematic builds of Debian packages, built them twice. At first, I just did 100 packages in a while loop, and then I just wrote a bit of code and tested all of them. And then Mike Perry and Sid Schön gave a presentation at CCC Congress in 2014, showing my graphs, and I was sitting in the audience, did not expect that, it was really nice. And I'll show you some slides of this talk, because it's really nice summary, why it's useful. So most people think, or there's a false ethos that users should have the source code and build the software themselves, but the only proof that the binary comes from the source is somebody said so. And that is probably not enough. And most people think also, I know that what's in the binary because I compiled it myself. And I'm upstanding, careful, responsible, I always watch my laptop. Why should I have to worry about hypothetical risk in the contents of my binaries? I'm not that interesting. But developers write code which is used by many people, sometimes millions of people. and billions, and they're interesting people. So there's been theoretical and practical attacks against infrastructure used by Linux, BSD, anything. There also has been in the Snowden papers designs from the CIA how to attack this, and this has been found in the wild. And they also showed nice compromise that is hard to attack, extremely possible, extremely harmful. Imagine the most secure computer in the world. Is this computer still secure if it's networked, accessible by others? You put USB devices in there. It runs strange Java code. Several nation states wants to access it. What if access to this computer gives you access to hundreds of millions of other computers, bank accounts, every Windows computer in the world, or what money you can gain from it? So they showed a small backdoor in OpenSSH, a remote exploit, where the diff is greater, equal, or it was greater and it had to be greater equal, and the diff in the binary is 1 bit. So if you look at this 500 kilobyte, 1 bit decides whether this is secure or not secure. And that's really hard to find. And that's also why we say everything has to be bit by bit identical. There should not be stuff which we can ignore, because it's easier to say everything is the same. They also built a nice kernel module which modifies the source code when the compiler builds it, but not when you look at it with an editor. So the source code is fine unless you compile it. And that was the graph they showed. The green packages are reproducible packages. The orange ones are unreproducible. And that is from end of 2014 till the end of 2015. And you can see there we reached probably 70% reproducibility in Debian back then already. So in 2015, Luna and myself gave a talk at FOSDEM, inviting the free software world at large to collaborate and tackle this problem. And here at CCC Camp, Luna gave a presentation showing many problems and their solutions, like what to do with gzip, what to do with tar, whatever. There's mostly options needed. And we had a summit in Athens where 15 projects, I think, were there to collaborate. And in 2014, we wrote the source date epoch specification, which I explain in a second. And we started writing diffoscope. So at first, the reasons for unreproducibilities we found are timestamps. Timestamp, and more, and build passes. And the problem with build pass is really easily solved by just rebuilding the same build pass and not randomizing the build pass on every build. And then there's the rest. And that's 422 issues we found, types of issues. And we have documented them. Luna gave this talk to explain them. And we made an unreproducible package which shows the problems you can have, because it's way easier to show how not to do it than to show how to do it. And so in the last 10 years, we've submitted 2,500 reproducibility-related bugs, 500. There's the West. 500 bugs are still open, but we also did more. We also did submit 20,000 bugs about mostly packages failing some source. So we found other problems while continuously testing Debian in this case. And there's more unexpected benefits of reproducible builds. Because if the software builds reproducible, then the compiler can cache a lot of more things, so it's way faster, especially if you build big projects. So it saves time for the developers and thus money for the companies. And for software development, it's also good to see if the change only really has the desired effect on this object or not other parts. And license compliance, you can only be sure you're running free software if the binary comes from the source. And the only way to find it out is to rebuild and have an identical result. And yeah, you get reproducible verified SBOMs also. So diffoscope. Who knows about diffoscope here? Few, way too little. Who uses diffoscope? Same people, more or less. So diffoscope tries to get to the bottom of what makes files or directories different. It will recursively unpack archives of many kinds and transform various binary formats into more human-readable form to compare them. So it has text and HTML output and supports many file formats. So it's whatever, Berkeley database, Debian packages, ELF binaries, Haskell files, ISO images, JPEG images, PGP signatures, whatever. And if it doesn't know the file type, it goes back to hexdump comparison. It has fuzzy matching to handle renamings and much more. And I show you a bit diffoscope. So this is HTTPS everywhere, Firefox extension with 2 different versions. And you see on the left side the 506 version, on the right the 507, or maybe you don't see it because the light is shitty. And it will show there directly the diff in the file, so what's in there. So it takes a tar archive and goes in there, blah, blah, blah. You have to be faster, you know. And so that also shows you nicely the diffs. There's also try diffoscope, where you can upload 2 files and diffoscope will then run for you. Else the web page and you can install it everywhere. Source date epoch. I'll skip this because they're a bit fast. So timestamps are meaningless because they vary at each build. So source date epoch is the time of the last modification of the source code because that is useful. And it's supported by a lot of software today, like 100 softwares, all the compilers, many documentation frameworks. And we have a specification which is like 1 or 2 kilobytes in size and is very stable. So we had many summits. We'll have another summit this year in Hamburg. And there were like 40 projects by now, which is really cool to collaborate. Which brings me to funding. We are a Software Freedom Conservancy project now since 2018. 4 people are funded by this. We need funding for the summit this year in Hamburg, and we need funding for our general work. Thank you for funding. I skipped most of the things now. This is the result for Debian Unstable for the last 10 years, so it's pretty stable. Trixie is pretty boring because Trixie is just 2 months old. And this is the numbers for Debian, so it's harder to read. The interesting part of the unreproducible packages, which are still way too many, 1,100, but it's only 3.3% of the software archive. The rest is reproducible. And so each release, Debian release, we get 3,000 more packages, but they're mostly the same number of unreproducible packages. We managed to change Debian policy in 2017, saying packages should be reproducible. I now want packages must not regret. And then new packages also must be reproducible. And then in 27 or whatever, all packages must be reproducible. And I would also like to see this faster, to have it 2 years earlier, that this year we already don't allow new packages which are unreproducible. And this 100% is a political decision, it's not technical. So we need to change Debian policy and say whatever the last 2% we just kick out. Debian needs to change the policy, not we. And 100% reproducibility in theory is not enough, because we need to rebuild us, and for Debian we need a working snapshot service. Transparency logs also, that we know which binaries we have installed, also for the non-reproducible packages this is useful. And we also need binary transparency logs. And this is true for all projects, not Debian. I'll skip the other projects a bit now. They're all in theory, it's nice. Even Fedora has now enabled finally a macro to enable source date epoch when building RPM packages. So today, many projects support reproducible builds, but it's unclear what it means, how it's enforced, and how users can know and be confident, because it's just in theory. We can do it, but we don't really do it. I call that reproducible in theory or in CI, and that is a massive success. This was thought impossible 10 years ago. And this is again from this 2014, which is all the other part. Infrastructure should be created independently. This has not been done yet nowhere, really. So in theory, we are done. In practice, we are just done in theory. So we need rebuilders. We need to store the results somewhere, and we need to define criteria how tools should treat that data. And then we need those tools also. And those missing 5% are also still crucial. At least 300 softwares need to be fixed to have the software which we all run. So in summary, many projects support reproducible builds in theory, but it's unclear what it means in practice and how users can know and be confident. And this is huge success. And now we need to finish this last bit. We need to create infrastructure for rebuilders. We need to create infrastructure to processes and tools to securely use those results. And we need project-level consensus and commitment to reproducible builds in practice. Thank you.
Thank you, Holger. I think we have about time for one very urgent question, maybe two.
Thank you. Great talk. So you mentioned at the beginning some caveats and like known issues. Is one of those the fact that when everybody runs the same binary, one exploit is enough to own everybody?
Well, that is a side effect, of course. But the result is not everybody runs scrambled software. Layers of protection or whatever you want to add there, but it's not.
I guess we can take that.
So you mentioned rebuilders, which are like a really interesting concept. Are there existing projects which make it easy to, for example, set up a rebuilder which automatically rebuilds like maybe all Debian packages and some others and then exposes them in a standardized format? So, for example, clients can have a list of rebuilders they trust and then check with all of them if the package is correct before installing it.
We have at least 2 rebuilder implementations, which are both used by different people. For Arch Linux is really nice working. For Debian, we need the snapshot service, which is not working, so rebuilders for Debian don't work at the moment.
So, with that, I guess we have reached the end of our time. And so I want to thank Holger again for giving this nice talk, and then enjoy the rest of camp.